everyone, we are from group 7. So we are doing falling film absorption unit for our project. So my name is Nur Hazika binti Mazlan and my group members are Sis Yu Ping, Katri Atik anak Nicholas German, Farah Jelengi anak Michael Gado, and Eliza Farhana binti Kushairi.
A gas mixture is in contact with a liquid during a gas transfer procedure known as gas absorption. Many variables including packing type, operating temperature and pressure, flow rates and concentration affect how well gases are absorbed. The problem is how to increase the efficiency of falling film absorption unit. The aim is to increase the effectiveness of gas absorption in oxygen-water system with modified falling film column. The objectives are to determine all the operating conditions in order to achieve the project aim, and to select proper instrumentations for the gas absorption in oxygen-water system to increase its effectiveness. Gas-liquid absorption is a process where the gas mixture is in contact with any liquid to separate and dissolve a specific component, and there will be a difference in concentration. In the absorption process of oxygen and nitrogen in water, the water surface is said to be remain unbroken although the liquid was. Falling film absorption unit with horizontal tubes was categorized as one of the most common equipment designed in commercial absorption systems. It is mostly used to calculate the liquid film mass transfer coefficients or to determine the coefficient values in power law relationship. The falling film absorption unit consists of weathered wall columns that are made by glass, the oxygenating columns that are filled with glass packings, water tank and feed pumps, air compressor, gas and liquid flow meters, and dissolved oxygen analyzer. The wall columns can act as an absorber which is used to determine the gas or liquid mass transfer coefficients in absorption process. A deoxygenating column is a type of gas stripping column that consists of a vertical pipe where water will flow downward and nitrogen gas will flow outward. A compressor is a mechanical device that is capable of transferring energy efficiently to increase the pressure of vapor. It is used to transport fluid materials in liquid phase from one point to another point. Flow meter, or known as flow sensor, is a type of flow instrument device that is used to measure the amount of liquid, vapor or gas passing through a pipe. A sensor is a device that converts input from the physical environment into output. A valve is a mechanical device in a system that regulates and controls the flow of fluid and pressure of the fluid within the system.
So the figure shows the block flow diagram of falling film absorption unit. In this process, dissolved oxygen in the water will be removed to produce deoxygenated water, and the concentration of oxygen in the deoxygenated water will be measured. Then, it will pass through absorption column, where the oxygen will be added back into the water to produce aerated water, and the concentration of oxygen in the aerated water will be measured again. Instrument selection is very important for falling film absorption unit. First of all, water tank. Water tank acts as a storage reservoir to create liquid film that interact with gas stream. Next, there are two columns, which are the oxygenation column and absorption column. The oxygenation column will help to remove oxygen from a gas stream, meanwhile absorption column facilitates the absorption of desired components from a gas stream into a liquid phase through efficient gas-liquid contact and mass transfer. Next, compressor provides necessary pressure and flow rate for the gas stream. Pump helps to maintain the desired liquid flow rate, ensures uniform coverage of gas-liquid contact surface. Valve also help to adjust flow rate manually or automatically. Sensors will help to monitor and controlling the process parameters, while flow meter will help to monitor the gas and liquid flow rates.
For methodology, the startup procedures are close all valves, fill some tank T1 with clean water and gas saturated tube with water. Turn on the control panel power, connect the all sensors to meters and let them stabilize for 15 minutes. Insert sensors into appropriate holders. Open valve V7, half turn, start pump P1 and fill the deoxygenation column with water above packing. Start pump 2. Adjust valve V10 for desired feed flow rate at Fi 103. Readjust valve V7 to maintain water level. Adjust flow restrictor for uniform liquid film absorption column's internal wall. Slightly open valve V5 for nitrogen to enter the deoxygenation column. Adjust valve V5 for 0DO at QI01. Start air compressor and set pressure regulator at 4 bar. Observe stable readings of both sensors for readiness. For experimental procedure, perform startup procedure from section 2. Adjust valve V4 for minimum water flow and record Fi02. Adjust valve V2 for 5 lpm gas flow rate at Fi01. When steady state is reached, record dissolved oxygen readings at QI01, which is C1, and QI02, which is C2. Calculate molar flux of oxygen using the given formula. Calculate average concentration difference Ca minus C infinity from Henry's law. Calculate liquid mass transfer coefficient KL using obtained values. Calculate Sherwood and Reynolds number. Repeat step 2 to 9 for different water flow rates, keeping air flow rates constant. Plot Sherwood number versus Reynolds number on a log-log graph and compare values with literature. For shutdown procedure, turn off pump P1 and P2, turn off air compressor, turn off unit's power supply, close valve V5 and shut down valve at nitrogen gas cylinder, close valve V2 and V4, open valve V8 to V10 to drain liquid from columns. If not using the unit for a long period, open valve V7 to drain water from something T1.
There are two problems that we encounter in falling film absorption unit. First, inconsistency of DO meter reading. DO meter is an extremely sensitive instrument where any changes in temperature and location can be detected. In an experiment of ammonia water, the graph trends are quite unstable for airflow rates due to the DO meter that has higher sensitivity. Second, gas flow rate sensor malfunction. Gas flow rate was manually measured by the anemometer, resulted in inaccurate data collection. Gas flow rate variation is detected during experiment, affect the efficiency and accuracy of flow rate in the system. Gas flow rate is low in the column, the driving force will be low as well for efficient mass transfer.
Hi, my name is Kiteri Atik, and I'm going to present the piping and instrumentation diagram part. So, this figure right here is the process flow diagram of falling film absorption column. And further explanation will be on the next slide. So, this is our PIND diagram. On the left side table is the specification about the equipment list and also its quantity. The process begins with the sparging of water and nitrogen in the deoxygenator column Q2. Then, the overflow from the deoxygenator column will flow into T1 and being pumped using P1 into the absorption column K1. The components labeled FL102 and FL103 are flow meter indicators which measure the flow meter of water and also display the output on the mechanical indicators. So, they are purposely placed behind the valve to avoid any velocity profile disturbance that might be caused by the valve. Components labeled QL101 and QL102 are oxygen sensors that measure the oxygen level in the water. Next, air is compressed using the compressor and pass into the K1, which is the absorption column. Then, the water flows down the internal side of the absorption wall column will dissolve the gas, and the water from the tank will be recycled back into the deoxygenator column K2.
My name is Fargalangi with metric number 79387. So this is the result that we refer from the lab report. For table 5.41, it is the result that obtained through the experiment. For table 5.42, it is calculated parameter used to decide Sherwood number and Reynolds number of each reading. For table 5.43, it is Sherwood number and Reynolds number of each reading. For table 5.42, the molar flux of oxygen is increased as the liquid flow rate increases. The increase of liquid flow rate has impact on the liquid mass transfer coefficient. Then the Sherwood number also increase. Simply said, as the liquid flow rate increase, so does the gas absorption efficiency for the falling film absorption unit. Figure 5.5.1.1 show the Sherwood number increase, so does the Reynolds number. The Sherwood number and Reynolds number in a falling absorption unit are perfectly proportional to each other. This is the solution to solve the problems in falling film absorption unit. First is accuracy of the ohmmeter reading. Since the inconsistent reading of the ohmmeter affected the graph track, set of experiments are repeated and done at the same condition and position of the probe. The system needs a lot of time to stabilize before the experiment is conducted. Next, routine maintenance of gas flow rate sensor fixed by doing routine maintenance on the falling film absorption unit, which will also help the experiment go more smoothly, the more precise the outcome will be.
In conclusion, gas-liquid absorption process is the main critical fundamental in falling film absorption unit. In the absorption process, mass transfer coefficients are one of the key that can be determined from mass and energy balance. The results from the experiment can be consistently obtained, and the effectiveness of the gas absorption in oxygen-water system can be achieved.